Hello, everyone. Can you hear me?
Yes.
Thank you. Thank you so much. Good evening to all of you. And I can see 8 students, which is about 5% of 160. So good to see you all. And now I'm just going to give you some brief about next module. What is the importance? What is the significance and related aspects? So that you can feel very comfortable in this module. Before starting, let me start and explaining few basic concepts. So I'm just going on whiteboard. Okay, can you see my whiteboard?
Yes.
Okay, perfect. Thank you. So so this chapter is about confidence interval. And this chapter is about estimating this is also beginning of inferential statistics. So far we were doing descriptive statistics. So do you know what is the difference between descriptive statistics and inferential statistics? Any idea? So
Descriptive statistics would be looking backwards and inferential would be looking forwards.
yes, very good. Thank you. So this is about, based on sample, we would infer about population. So this is population, we take sample. Based on this, we infer about population. So this is what we are going to do from this chapter onwards. And here we see the confidence interval. If I ask someone, what would be your next year's salary? I mean, just for example, next year's salary. And, next salary for 2024. You will not be able to give me like, 100,248 dollar and 20 cents. Means you will not be able to give exact figure. What you can give me, that it would be between 100 to 100K to 110K. So basically you will be able to give some range. What would be your GPA at the end of the day, end of the MBA? You can't say 3.94 exactly. You can't predict this. If you can predict this much certainty, then you are wonderful. You are God gifted, but you will be able to see between 3.9 to 3.95. I mean, such kind of information, such kind of range you can give. So this is what we are going to see. We are going to check this range. We are going to estimate this range based on 5% confidence interval, based on what 5% significance level, 10% significance level, or different significance level. So what is the difference between confidence interval and significance level? So let me also explain that concept. It is. So in previous chapter, you have seen that previous chapter, you have seen this total curve is 100% or 1 or 1. What is 95%? That means you can say middle 90% would be this. So 5% here, this side, 5% on this side, and this is 90%. So in this case, this 90% is called confidence interval. In statistics, this is called confidence interval. And this 5% and this 5%, 10%, this together is called significance level. So this is the difference, and you can, if you know significance level, you can get confidence interval or vice versa. Third thing, let me take a real example that I talk about, because I have the real data, so I can talk about real data. Let me talk about a real situation. So I have a question. I have a situation every year about US has more than million students. More than million students are international students in USA, and every year about 20, 25, 30,000 students from India, they come here to pursue master's and PhD degree. So about 22,000 students come. If so, during this is past year data. I want to know what is the GPA of all the students are coming from India. So I want to know the GPA or C of all 22,000 students coming from India in United States. What's their GPA? In India, GPA is 1 to 10 point scale. Like here you have 0 to 4. In India, 1 to. So what I do, I can't, United States immigration, they don't record the GPA of the student. And and they are scattered across US in different universities. It's a very difficult how one can, even no embassy records, what is your GPA. They record, students, other information, but not statistics like GPA, GMAT, or GRE. So this is, I collected a 500 students data, 500 Indian students data. And based on 500, I collected GPA, I collected TOEFL score, I collected GRE score, I collected English score, and what kind of university they are in. So based on that, I would like to know what is their GPA of all the population based on 500 sample. And so I have that data, and I'm going to show you. So let me go with showing on Minitab how to do that. And let me go on Minitab. Can you see my Minitab?
Yes.
Yes.
Okay, perfect. So this is Minitab. This is, oh, sorry. So this is the data I collected here. These are the students, 500. Their GRE score, TOEFL score, university rating, in what kind of university they are in. Statement, there are two other important part of student admission. One is a statement of purpose, second of letter of recommendation, that they get letter of recommendation from their ex-professors or from organization they work. A statement of purpose, why they want to do this program. And so GPA or CGPA in Indian on 10-point scale. Two types of university. One is research university, one is teaching university, like Eastern is teaching, Eastern is WSU is research university. Chance of admission, these are their chance of admission. So this is the data that I have. Now I'm just going to see, based on these 500 students, what are their chances of admission? What are the chances? What is the all 22,000 student GPA? I will not get one particular number, but I will get the range. So I go under statistics, I go under basic statistics, and here I have one sample T, one sample Z. I will let you know when do we use one sample T, one sample T, Z or T. So here, this is the option. Why we are doing here, you can put the summarized data. That means you can put the You can calculate the sample size like 500. You can calculate the mean of this, and you can calculate the standard deviation of this 500, and you can put, but since we have the data in the row or column, we are just going to use this and GPA. And this option I'm not clicking because this will be used in next module. And here, this is 95% confidence. So what we are doing, 95%. Now you can see. So basically, we got the answer right here. And now I'm going to describe, or I'm going to explain this answer. So here you can see the mean is 8.57. This is mean GPA of all 500. 95% confidence interval for mu. You can see the symbol has been for population. 95% confidence interval for population. Population mean. And here you can see 8.52 to 8.629. That means what is the, so based on this 500 students data, I can say I'm 95% confidence. I'm 95% confidence that the students, all the students from India coming, their GPA between 8.52 to 8.62. So I got this range. So basically I can estimate between this range to this range, I can with 5% possibility that it may not be there. So we are taking 5% risk. Are you getting me? What is the importance of this part? So that is the importance. And similarly, you can predict anything. You can estimate, what is the confidence interval, what is the lower limit, what is the upper limit. Now let me show you on whiteboard or here. So basically 8.5764, and this is, let me copy this and let me use on whiteboard. Similarly, we can do for proportion. What is the proportion? For example, research university. This is the proportional case because here, 1010, you can say. So here I go, what is the chances? So basic statistic, 1 proportion. And I can directly take the research part because this is, and again, by default, 95%. And here, this is the proportion. As of now, based on this data, 56% students, or 0.56, they are in research university. What is the chance? All 22,000, what is their chance of research university? Between 51 to 60%, or 0.51 to 0.6. So this is the interpretation. Now, let me go into the slide part and explain. So I'm just going to change. I'm just opening the slides. So can you see my slide part?
Yes.
Okay, perfect. So as you know, after, if you have large sample size, all the distribution becomes the normal distribution that and you have studied in past chapter. So we are just doing this. So what are the two important parameters based on that, or two important? One is mean, second is proportion, third is standard deviation. So we are going to estimate these things. Mean, what is the population mean? What would be the population proportion? What would be the population variance or popular standard deviation? So these are the three things we can do. So rest is, just let me go directly. This is all distribution becomes normal distribution when you have sample size. So this is most important formula that you need to keep. And some of the questions are based on this. Directly based, or you just need to add little bit from your side in terms of thinking, and then you can answer questions. Mu plus minus z sigma upon square root of n. So this is the most important formula. What is mu? Population mean plus minus z value from the table, or z distribution, sigma value square root of n. So this formula can be used when you have population standard deviation given, means sigma is known. 90% interval, mu plus minus 1.6. This is the value that we get from the directly from z table. Sigma square 95. This is for 95. This is for 99. So this part, sorry. This part after plus minus is called margin of error. What is called? Margin of error. And this is called standard error. Standard error means sigma upon square root is known as square root of n. So only this part is known as standard error. The complete including z is known as margin of error. So some questions in the fill in the blanks are asking only plus minus part, which is they are asking margin of error. So some of you are doing the direct, full, don't do only margin of error part, don't include the mu part. Now, another important thing you can see, you want to predict it precisely, you want to estimate it precisely, means how you can do that estimation if your range is very narrow. If range is very small, means your prediction is more accurate. How you can do that? So from the formula, you can clearly see if you increase the n value, that means everything in this, margin of error will be reduced. If n value means sample size is large enough, then you can reduce the margin of error. If sigma value is very small, means in data or data that you have, the consistency in the data means sigma is very low, low variation, low standard deviation, then you can predict very accurately this or with a small range. And the z value. Z value means where you have least value, here you can see. So you want to reduce, what should be the z value? It should be high, it should be low, or it should be, means if you have confidence, this interval is smaller and smaller, means this value will be smaller, then you can predict very high, means very accurately. However, there are chances of, opposite chances of risk is also there. So how you can, your purpose is to get this part smaller, because this remains same. And so now I think I already explained. If you see sample size increasing, this part is decreasing. So you need higher sample size in order to get precise value. So what is confidence interval? on one side. So sigma upon square root is a standard error of mean. Now, this is a confidence interval, which I already explained, 90%, 95. So this is mu plus minus, mu plus minus. So this is a minus term, this is a plus term. Means how you can know the left side and right side values, that is important. Greater confidence interval means loss of precision. That is greater margin of error. 95 is the most standard and most often used, and by default it comes. Higher confidence level leads to wider confidence interval. That means you are predicting with 99%. Okay, you will get bigger range. However, you will get bigger range. You will lose the precision. So what is the meaning of that? What is the meaning of confidence interval? Let's say you are doing any experiment. So here, out of 100 confidence, approximately 95% may contain the true mean, contain mu. 5% might not contain mu. So this is the meaning of confidence interval. I will explain other way. This is the thumb of rule. Please look into that. When we can use t-value, what is the thumb rule? What is the sample size? 30 or more than 30, where t-value and z-value becomes almost same. So now when we can use t-value, when population standard deviation is not given. X bar you can clearly see. So X bar, which is sample mean plus minus t-value, sample standard deviation, and sample size. So there's no difference between Z and T in terms of understanding. Only instead of population, here we get the sample items. So same thing, when we can use Z value, when we can use T value, how do we get this degree of freedom? Sample size minus 1 is degree of freedom, which like 20 sample size, then degree of freedom 19. Confidence for mu with unknown sigma means population standard deviation is not given. Then in that case, t values, then we can use t distribution. So this is construct 90% confidence interval for a mean GMAT score of all MBA applicants, where X bar equal to 510 and standard deviation. So here they are clearly given. Sigma is unknown and they are giving clearly. So you always distinguish between sigma is given or S is given. Accordingly, you can choose. So I'm just going to use Minitab and one sample T, and here summarize data. I have to see what is the X var 19. And so sample size to 510 and 73.77. Sample size is 20. And what is the level of confidence? 5% means they are asking 10%. So 510 is the mean. I did a wrong standard deviation, I believe. Okay, 7. It is rounding. It is rounding. So 73.77, which they are rounding to 73.8. Standard error of mean, and this is a confidence interval. with 90% confidence, GMAT score will be between 481 to 538, where 510 is a mean. With 90%, all GMAT applicant there, or all GMAT, all students GMAT score will be between 481 to 538. So this is the interpretation of. With 90%, still there is 10% chances that it will not be there. I will explain on whiteboard what is this confidence interval. So this is you can now look into this. This is very important. So 510 plus minus 1.729, this is a t-value, 73.77 square root of 20, or 520 plus 28 points. So can I do the white? Okay. Please remember, this is the part, or this is the question in most of the fill in the blanks. Please think, if it is giving plus minus or asking plus minus, means they are asking this margin of error value. So if you subtract 510, subtract 28.52 with 510, you will get lower value. If you subtract this part, or if you add this part with this, you will get the upper value of confidence interval. So this is subtract value. When you subtract, it is coming this. When you add, it is coming this. So 481 and 538, what we get here? .481 and 530, same value. So in Minitab, if you subtract with this, you get 510. So 582 means how you can get margin of error here. You can simply do this. 510 minus 481.5, you get this margin of error. What is the value of margin of error? Or otherwise, how you can get 538.5 minus 510? This is the way you can get margin of error. If this is clear, let me go further.
So you're saying a margin of error is that confidence interval?
Margin of error is z value or t value plus a t value multiplied with standard of error. So this is the, so let me go. So margin of error is this z or t. I'm just writing sigma upon square root of n. This is called margin of error. Means after plus minus, this part 28.52, this is called margin of error.
Okay, that's what I wanted to know.
Yeah. And this is just, average or mu, or so you can, yeah, this is the margin of error, this part. This. And only this standard error means where standard deviation and sample size. So this part is known as standard error. So beyond degree of freedom, all these things, because when you have, now we come to the proportion. So we were talking about the mean. We will talk about proportion. If you want to see the proportion, what is the proportion? This is x upon n. Like we did in binomial, what is the proportion value of pi value or p value? We can, so pi and standard error. So this is when pi and, so this is a formula here. When pi is 50%, this is symmetric standard deviation. Now, here you see, when pi is large enough, it will be normal distributed. This is the formula. And in this formula, if you are going to estimate the confidence interval based on proportion, this is the margin of error for proportion. This is proportion, P, which is like 20%, 30. And this part is Z value remains same, N value, and this included. So directly Minitab gives us the value. So here you can clearly see this is 0.32%. And so let me show you one example right here. Graph, sorry, basic statistics, one proportion. We are just talking about one proportion as of now. Summarized data. You can do, what is the summarized data here? Number of events and number of trail. So here we have 24 and 75. So 75 retail in a store. So 24 were paid in cash. So 24 divided by 75. And again, 95%. And you can see 32% sample proportion and confidence interval is this. So basically, this is confidence interval for proportion. Now, very important question is here, and this part has been added when you have finite population. From population size is also given, sample size is also given. Then this part is included, which is called population correction factor. Finite population correction factor, which is square root of capital N, which is population minus small n divided by capital N minus 1. So capital N is population, small is sample. And if that is the case, all three formulas, all three equations are having this extra factor. So you can clearly see this is same Z value, this value, this is added in this formula. So basically this is about, it impacts like 9.9, whatever value you get of this, it multiplied with about 0.9 something. I don't remember it. So about 90. So this is also, you can see T value or based on sample. This is included in proportion. This is included. So basically this is finite population correction factor if question has this. Now, after this, very important concept of the chapter or that we have. How do we calculate the sample size for any study? Suppose you are conducting any research, and how you can decide whether 200 participant will be enough, 500 participants will be enough, or this or that. For that, we have the formula based on here and sample size based on estimate to estimate mu. So here, this is how do we do. And as you know, this is error part, error equal to, or margin of error equal to Z sigma upon square root of N. In order to remove N, square root of N, we do the square of both the side. So this, this is margin of error formula. To remove this square root, we do square. Now we do this N, which is Z square, sigma square, E square. So N equal to Z sigma E and square. So basically, if you know these three numbers, you can calculate what should be the sample size. Now, another question, how do we calculate, Z? Okay, if we are going to do the study 95, 90%, we can get the Z value from here. Sigma value, how we can get the sigma value? Sigma value, we can estimate from different, based on Poisson distribution, based on empirical rules, based on other aspect. Range, based on range, we can estimate. For a very simple example, plus source range equal to, what is the range equal? If you know that, in this population, the range is between 2 to 20. 2 to 20. So highest is 20 minus 2. And then, range is 6 sigma. So 18 upon 6 sigma. So range is, so you can see the sigma equal to about 3. So this is 6 sigma equal to range. And range is, so sigma equal to 18 upon 6. So sigma equal to 3. How we do this? Just, based on the normal distribution. If you remember this distribution, this is a mean and plus minus 3 sigma. The almost 99.73% of data will be covered, or values will be covered. So we approximate that, entire range is covered in 6 sigma. So 6 sigma equal to range. So sigma equal to, and we can calculate. There is a other way to calculate sigma based on, if average in Poisson distribution, square root of average is sigma. So this is the way you can calculate. So here, how to estimate sigma? First, to do this using before going to actual study, you can take a sample of, and based on that sample, you can calculate S based on sample of 20, 30 or 40 people, and you can get to know. Second, assume uniform distribution. For uniform distribution, this is sigma value. Assume normal population. This is what I explained. Sigma equal to range divided. So this is the, if you assume Poisson distribution, sigma equal to square root of lambda. So this is the way you can calculate. And margin of error, you can consider 5% or 10% margin of error. Then you can calculate your sample size. And I will show you this. For proportion sample size determination, for mean, we just learn for proportion. And here, this is the same formula can be. So here, P plus minus Z, this is general form. So P equal to, so this is error form is equal to, here error form equal to this. Z square root of pi 1 minus pi upon E square, same thing, N equal to Z. This is the formula. So N equal to Z upon E, which is error, pi minus. So for large population, pi is almost 50%. This is the assumption that if you have high population, we assume 50%. So I'm just go through the assumption. Assume 50%. This is a conservative method or rule. Take again, do the preliminary sample, and based on that, estimate the pi. Use the historical, based on historical data, you can do that. So pi, how to estimate? Rule of thumb, I mean, if you don't have, use 50-50. Take a sample, pilot sample, and third is based on historical data. That we were doing many questions in binomial distribution. So this is the method. The third thing we mean, proportion, and third is standard deviation of variance, how we can predict or how we can estimate a standard deviation of variance. For that purpose, we have chi-square test. Chi-square test and degree of freedom n-1, upper or lower limit. You can, this is chi-square is sigma square is variance, lower and upper limit. And how we can do that? Our Minitab gives us direct results. So this is for variance, proportion, and mean. Now, let me go and explain through this. I hope you can see now my Minitab part.
Yes.
Yes.
Okay, so here we go under this basic test, and here we have power and sample size. So here we have different options. One proportion, one sample Z, one sample T, one proportion, one variance, one way ANOVA. So different sample size estimation. Okay, so here, like we did for proportion, we did for mean. Now just, for standard deviation, let's say we calculated based on range or based on different. If you know the standard deviation, estimate sample size, or estimate margin of error, you can estimate sample size. Margin of error, if margin of error is given, then you can directly calculate here. So let's say I'm just randomly putting some value. Standard deviation is this, margin of error, let's say 0.3. Here we have different options. Assume population and standard deviation is known. So I'm just doing this. Sample size is 387 for that particular where standard deviation is this. Now I go again, sample size, mean, standard deviation normal parameter, variance, proportion. So you can do for mean Poisson situation when you have lambda given, then square root of lambda will be. So variance, you can choose different options. Here you can also have different other option. You can normalize this. You know what is the condition of normal. So here you can change the numbers and you can get. There's a very important thing that you must remember. That question is given in sample size estimation. If you do manual calculation and if you use this calculation, means Minitab calculation, the answers are different. Answers are different. Let's say here you are getting 387. When you do manually, probably you will be getting something different numbers. So what I did, I calculated using manual and I calculated using this, and I put the margin of error with answer, so that either method you will calculate, both answer will be correct or in the range will be correct. What is the meaning of that? Let's say I'm just calculating using this Minitab and I'm getting 387, and you will calculate same by hand, just manual calculation. Let's say you get 392. So my answer would be I set 387 and I set plus minus 5. That means within the range of 392 to 382, the answer will be accepted. So this is what I did in order to avoid this problem. So this is another aspect that remember, and don't get panic that the answer from manual calculation and from the Minitab are different. Probably some algorithm behind that. I was not able to figure it out why they are different. I reported to Minitab. I did not get any response. So this is the part. So this is what is about chapter. Let me give you one more important aspect. What is this confidence interval again? So let me share this whiteboard. And let me explain on whiteboard. Okay, let's see, if you take 100 experiment, or if you do 100 experiment and 90% of experiment or 95% of experiment fall within the range, then that is 95% confidence. Let's say I'm just going to do, this is my mu. Let's say this is a mu. And I develop this confidence interval. Let's say this is my, mu. This is mu, and this is my normal distribution. Here is plus minus 3 sigma. First time I'm instead of 100 times, I'm just taking 10 times. First time I took a sample, and that sample mean is coming here. The sample mean is coming, its confidence interval. That sample confidence interval is coming here. Okay. Second time I took the sample, that mean is coming here, and its confidence interval is coming here. Third time I took mean, and third sample I took out of 10, and this is mean is coming this, and its confidence interval is coming here. Fourth time I took, let's say I'm just doing this here, and its mean is coming here, its confidence interval is coming here. Fifth time I did, and it is like here. Sixth time I did, let's say here, and it is here and to here. Seventh time I did, let's say here, and it ranges from here to here. Eighth time I did, it is coming is actually here. Ninth time I'm doing, it is like here. Confidence interval is. 10th time I did this, and it is here and here. So I did 10 experiment, or I take sample 10 times. Out of 10, what is happening? Nine times sample is representing true population mean. So for example, this sample, the confidence, its range is here, confidence. Only one time, which is this. So this is, in this case, this is called, I'm 90% confidence that this interval will represent true confidence, a true population mean. Only one time, which is about 10% in this case. So if you do 100 experiment, 90 times it will represent true population mean, or it will. Therefore, in words, we say, I'm 90% confidence that true population mean will be within this range. But same times, we have 10% chances that it will not be there. Similarly, 95% confidence, 5% chance, 99% confidence means 1% chance that it may not be there. So do you understand? I try to simplify what is the meaning of 95 or 90% or different confidence interval. Is it making sense? If yes, so this is the module 4. If you have any question, please let me know. do I have little, throat throat issue, means cold kind of thing. So if you don't have any question, I would like to say a wonderful night, and we will see next week. And in between, if you have questions, please send me an email. I will reply as soon as possible.
Thank you, Vitul.
Thank you.
Okay, thank you.
Most welcome. Thank you.
Thank you. Good night.
Most welcome. Bye. Good night. Thank you.